Welcome, everyone. My name is John Small, and I'm going to be chairing this session, which is on Arctic and Alpine environmental change. And I'm delighted to be here. We were going to talk about cold regions primarily and why they're so critical in an environmental perspective and in an ecological perspective. We live in a very rapidly changing environment, and we often hear about Arctic and Alpine regions as being the most sensitive to environmental change, and there's very good reasons for that. One of the clear ones is climate change. The Arctic and Alpine regions are the first to show signs of environmental change, and they often do so to the greatest degree. They're also equally important in that they affect other types of ecosystems. What happens in the Arctic affects us all. I'm a Canadian, and from a Canadian perspective, the Arctic especially is perhaps important for our world. We live in an environment where in my country, about one half of the country is technically the Arctic, and about 2/3 of the coastline is the Arctic. We also have certainly alpine or mountainous regions throughout the country. And of course, Austria has a polar program, and of course is famous for its alpine environmental work as well, which we'll be focusing on here today. We live in a very complicated world, and some of the things we'd like to discuss here is what a complicated environmental world we've come to see. We're seeing that land-based ice is melting, both in the Arctic land-based ice and in alpine glaciers. This can have both short-term positive, but also very serious negative impacts, not least of which is ocean water levels, but also for people who use, for example, alpine glacial water as a source of water. For a certain period of time, the water will be flowing very quickly, but eventually on some of these alpine glaciers, the water will stop. And of course, the alpine glaciers are like the water towers of the planet. And once that stops, then there'll be going to be very serious repercussion. We do some work in the Andes, for example, and we have ice caps that are disappearing very rapidly. And when that source of water disappears, I think we'll be in a very serious situation. The way we're going to try and do this panel is there's 5 panelists, 2 representing the Royal Society of Canada and 3 from the Austrian Academy. And what I thought we would do, I'd first introduce myself, what I do, and then we would go around the table, and I would ask each panelist to introduce themselves and what they do and what they believe are the most important issues, hopefully under 5 minutes each to do that. And then we'd have more a general sort of panel discussion on some of the major issues that we have to deal with. We'd like to reserve the last 15 minutes for question and answers from the audience. My phone just went off. I thought it was off. These are all the things we learn with Zoom calls now. And we'd like to reserve the last 15 minutes for questions and answers from the audience that we have. So maybe I'll just introduce myself a little more fully, and then we'll move on to the other panelists. Again, my name is John Small. I'm here primarily as I'm president of the Academy of Science of the Royal Society of Canada. And the Royal Society of Canada has 3 academies. It's not just the Science Academy. We have the Academy of Science, the Academy of Humanities, and the Academy of Social Sciences. We also have a College of Young Scholars and researchers. So we're now, in some ways, we have 4 independent type units. I am a professor I hold the title of Distinguished University Professor at Queen's University, which is in Kingston, Ontario. I'm in the biology department. And I also hold the Canada Research Chair in Environmental Change. And what I am is a limnologist. I work on lakes. I am primarily a paleolimnologist. So instead of just working on present-day lakes, we look on present-day lake ecosystems, but we also work on the history of lake ecosystems using lake sediments. And we look at the history of ecosystem change, where we think a lot of the answers lay hidden, especially when we try and decipher what is natural and what is human caused. About 1/3 my program is in the Arctic, especially the high Arctic, where I've met at least 2 of the gentlemen on this panel, Gunther and Derek. But we also have a significant program in alpine regions, especially in the South American Andes, but also in the Rockies and other high altitude regions. And so we work on a wide spectrum of issues, including climate change, contaminant transport, but we're basically ecologists. We're basically looking at biological indicators in lake sediments. So then I would just maybe like to go around and ask, I'll start with Dr. Lindsay Nicholson, maybe perhaps to discuss what she does, or introduce herself and discuss what she does, and we'll go down the list in this way. Thank you.
Thanks very much, John. My name is Lindsay Nicholson. I'm an assistant professor at the University of Innsbruck, and I'm a glaciologist. I started my career actually more looking at glacier geomorphology, but over time I became much more a process glaciologist. And in fact, although I'm based here in the mountains of Innsbruck, where the glacier research targets are pretty close, I also spent a couple of years working in Canada, where I've worked on ice cores from the Canadian Arctic, as well as helping at least map previous coastal shorelines in the Queen Elizabeth Islands. So I have a kind of connection to both, but I'm really interested in this panel because of the possibility to discuss some of the ecological impacts, because my own research focuses primarily on different mountain glaciers, and I've been lucky enough to work in different parts of the world, in the Nepalese Himalaya, in parts of the high Arctic in Svalbard, also in the mountains of Chile, where there are severe water resource constraints, as was mentioned already. And now my work in the Alps here really relates to monitoring glacier change and understanding the exchanges with the overlying atmosphere and how we expect those to change in time. But of course, the message we have here for the glaciers in the European Alps is that depending on the emissions scenarios going forward, we may see that children of our generation will live in an Alps essentially deglaciated. And of course, this is just, it's a profound kind of cultural shift. But as well as that, there are certainly like strong ecosystems and water resource and process impacts. There are changes on the seasonality and expected runoff from the mountain regions, and also sedimentation and all the knock-on impacts on the ecology and human societies that can be expected. And that's really the area that a lot of glaciological research is in now in terms of mountain glaciers. We know that the glaciers are retreating strongly, in some places will disappear, and we're interested in the impacts of those things. But considering changes in the Arctic ice, there's actually really substantial concerns as to what the impact of meltwater from melting land ice will have on the oceans and ocean circulation, and these things will have profound impacts at a global scale. And there's a real disparity because the impact of rising sea level from melting land ice will not be felt equally across the globe, of course. And so this is one of the ways in which change in these specific regions is of concern to communities very far away from them. And of course, we have the concern of like the profound change in the reflective properties of the Arctic region as it loses its ice, particularly if when the Arctic Ocean becomes ice-free in the end of summer. This is thought to have a significant effect that really compounds the effect of anthropogenic greenhouse gas emissions up to a level of about a quarter of the impact over the last 4 decades. So these are like substantial environmental feedbacks that we're triggering and are setting off, and we need to understand how those will evolve in the future. So that's my interest in what I do.
Oh, that's excellent. Yes, and it raises the issue of, we might call it social injustice, that many of the people who are going to be most on the front line of all these problems aren't the ones who cause the problems, whether it be climate change or contaminant transport or the other things we'll be talking about. So this definitely has a strong social background to it as well. Maybe that will nice segue into Derek Muir. Derek, if you would be able to introduce yourself and tell us what your perspectives are and what your concerns are.
Well, my name is Derek Muir. I'm a senior research scientist with Environment and Climate Change Canada. So for those of you familiar, it's the Canada's federal environment department, and it changed its name about 5 years ago to include the word climate change. This is a signal of how the government was focusing a little bit more on that topic. So in any case, I'm part of a division which does water research across Canada, and but for the past 30 years or more, I've been doing work on Arctic samples. So that's as an environmental chemist, I came at it differently, I think, from the other members of the panel, in that I was really interested more in the chemicals, and then got interested in the fact that the Arctic and actually Alpine regions that were.
Derek, can I interrupt you a second and ask you to maybe move a bit closer to your microphone?
Okay.
I'm struggling to hear.
With Zoom calls, I'm sorry, this computer I'm using varies a little bit. Can you hear me better now?
Yes, that is clearer. Thank you.
Much better. Yeah.
I'm sorry. Anyway, I won't repeat myself, but let me just say that as an environmental chemist, I really come to the topic of Arctic and Alpine science and climate topics through thinking about the fate of chemicals and essentially using them as kind of indicators. So the Arctic is a sentinel region really for environmental contaminants in a way, but not because it's highly contaminated, more because it's a background region. And at the same time, there's remarkable high bioaccumulation in some top predators, and possibly people listening to this and watching have heard of contaminants in polar bears and top predators like that. But so that's part of the work I've done. But what we come around to having as a result of 30 years of measuring chemical contaminants is suddenly realizing we have long-term time trends, which are of interest from the point of view of how climate factors may be affecting them. So that's, I think, what I hope I can contribute to this discussion. And actually, we've been very lucky to be working with one member of the panel, Winter Cope, for about 25 years on this. And he actually started a project, which I'm going to describe very briefly here. What we were looking at is Arctic char in lakes in the high Arctic. These are very unproductive lakes in a way, very clear waters, beautiful site. And in fact, if you can see my image, you can see one of the lakes behind me that I'm using as a background for Zoom. And we're following annually the trends of pollutants like mercury and persistent organic pollutants like PCBs in the fish. So with almost annual samples, we're getting a trend of at least 20 years and sometimes up to 30 years where we've been able to go back into the freezers and get old samples and look at these trends and then examine them from the point of view of some of the changes that are rapid changes that we're seeing climate-wise. One of the most rapid changes is the decrease or the increase in the time when lakes are open in the Arctic, and trying to see if we can link that to some of the trends that we're seeing annually, the annual sort of year-to-year variation. We're seeing some effects, but I have to say that perhaps that we need to be looking over a longer time trend to see really, to get stronger correlations. But we're seeing some effects of issues such as ice cover, the duration of ice cover. That seems to affect, for example, how mercury behaves. It's a chemical which can actually volatilize out of lakes as well as enter them. So ice cover is important for them. And another factor we're seeing is turbidity. We're seeing a large increase in turbidity, and it's been mapped across parts of the Canadian Arctic. And more turbid lakes have major implications for both wildlife, and especially for fish, but also for people, because in the Canadian Arctic, the lakes near communities are usually drinking water supplies. So our work then is sort of, whilst it started as a simple chemical monitoring story, has sort of morphed into a study which we're trying to link climate variables to and other factors. And so I look forward to the discussion here today with the glaciologists and the paleoecologists, because we're more and more trying to use information that they're publishing and their understanding to interpret our data. I'll stop there.
Thanks very much, Derek. Just one thing, Derek, if we hear you much better, but now we only see about half your face width. So if you could
I'll back up.
adjust, okay, good. Thank you. And yeah, the power of monitoring is, I think, what Derek's program is showing. It's something very hard to maintain often in a government or any agency, really. But we only know where we're going if we have the background data to do that. Thank you, Derek. Maybe I'll move to Jakob Aberman, and you can introduce yourself and say what your perspective would be.
Yeah, thank you very much, John, and hello, everybody. My name is Jakob Aberman. I'm assistant professor at Graz University in Austria. My background is meteorology and glaciology, and I graduated from Innsbruck University a decade ago. And from there on, I moved, I was interested, my starting interest in research were actually how the atmosphere impacts glacier changes and how we can determine this kind of on the glacier side, but also always how we can determine the drivers that actually lead to these changes. So I think this connection between atmosphere and ice is a very fundamental thing and very important for our understanding of climate change. From there on, I moved to Chile and had, as Lindsay also did, some really interesting years looking at the real impact of catchment changes in ice-covered catchments and snow cover and so on. And then I spent 5 years in Greenland, living there permanently during these 5 years, where I got more and more involved in ecosystem interaction and the climate side of it. And I was in charge of some projects basically providing these background data, as Derek also put it very nicely, where we needed to, or where we intended to understand what is actually the climate data we need, in which quality and which precision, in order to understand many other ecosystem consequences, among which hydrology or biology or many other aspects, of course, can be mentioned. And we had there is a very extensive program on that in Greenland, where we had success with one very important aspect of this, namely the interdisciplinarity. I think this is a very important point we should consider, and I would like to also bring into this panel. When we look at changes, and it's very subtle changes that are not very easily detectable, then we very often encounter some extreme situations, and they, of course, come unplanned. So we have very big benefit of good background data that we can relate to, and not just background data that is specific to one discipline, but background data relevant for many other disciplines. I would like to mention one example. We had a very snow-poor winter in Greenland, in West Greenland in 2016, and we were in our regular snow monitoring and tried to make our transects, but basically we found there was hardly any snow left. And for that we then, while we were monitoring this, we discovered everything was full with avalanches and slush flows that reached to the valley bottoms. Okay, there was an interesting observation, but the beauty of this was then that we could go back to all the climate data, we could go back to all the hydrological data, could see, was it actually something special? And then we found, yes, it was one of the largest avalanche events we have monitored actually in the world by then. And we could then relate this to other ecosystem implications later on. So I think this integrative approach is something very important. And of course, we are limited to a short observation time. And I think in this context, historical observations should not be underestimated. And I was lucky to, in my research, also to be able to dig out some of those very valuable archival data. And I think putting this into perspective is something important too in this context. Finally, I would like to mention that as in Canada, in many places of the Arctic, and in this case I would maybe take the voice for Greenland, we should not forget that there are people living who actually depend on these ecosystems, and improving our understanding of these ecosystems and of the variability of the changes will also put the foundation in order to keep this very special and resilient group of people into a modern future, and be able to give them the background information they need or we need in order to tackle those problems. With this, I would like to close and thank you for your attention. Looking forward to the discussion.
Yes, thank you very much. Excellent. And Gunter, could you introduce yourself and tell us your perspective, please? You'll have to unmute yourself, though.
Sorry about that.
This is going to happen. This is going to happen several times, I'm sure. So, but I'm going to do it. So.
Well, my name is Günther Köck. It's a little bit difficult to explain what I'm doing because my professional career is resting somehow on two pillars. The dominating one is science coordination, and the other one is environmental research. On the one hand, I'm since more than 15 years the coordinator of the international research programs of the Austrian Academy of Sciences, including 3 national committees. One of them is UNESCO's Man and the Biosphere MAP program. I'm the Secretary General of the Austrian MAP program and currently also one of the vice chairs of the international MAP program. And according to that, I'm intensively involved in UNESCO's worldwide network of biosphere reserve. And on the other hand, I'm still active in Arctic research as an associate scientist at the Institute of Interdisciplinary Mountain Research here in Innsbruck. I'm a trained fish biologist, and well, in the 80s, I focused my research on heavy metal pollution of aquatic ecosystems, and in particular, by using fish and aquatic insect larvae as bioindicators of water pollution. In Arctic research, I have to confess, I came rather by accident. In the 1980s, these have been the heydays of water pollution in Austria, I would say. In the course of our research on Austrian rivers polluted by industrial effluents, we decided to use fish from high mountain lakes. From that, we thought that they, at that time, were extremely pristine, and we wanted to use fish from there as a reference for background baseline metal concentrations. But to our great surprise, fish from these extremely remote lakes, they are up on 2,200, 2,400, 2,800 meters. These fish had much higher cadmium and lead concentration than those from fish in the polluted lowland rivers. Further analysis indicated then that the lake temperature might be the driving force for this increased metal uptake, and thus we suspected the possible influence and the possible link to climate warming. My idea was then Arctic and Alpine lakes are very similar and sensitive ecosystem, and moreover are populated by the same fish species, which is Arctic char. And my idea was if you could find similar results in the Arctic, we would have something like a global biomonitoring system for the effects of climate change on aquatic ecosystems. And on this basis, I started to set up this Austrian-Canadian cooperation, High Arctic, in 1997. I think 2 years later, my friend, colleague, Derek Muir, he's a member of his panel, joined the project, and then the small project really took off, and now it's a well-known long-term project with a focus now on mercury and persistent organotoxicant, but also many other scientific aspects. So since 1997, I work every summer in the Canadian Arctic, except last year because we were blocked by COVID. Let's see what the upcoming summer will bring, but I'm not very confident that we have the chance to work in the Arctic. Maybe what I want to say is that I'm very much influenced now due to my work for UNESCO and protected areas, and I got increasingly involved, interested, let's say, in the effects of climate change on the resilience of ecosystem and also on our society. Jakob mentioned the people living in Greenland, which are very much affected by climate change. The same is true for the Inuit people in Canada, and the same is true, of course, for the people living here in the European Alps. And maybe we have a chance to discuss about this a little bit in this webinar.
Yeah, I think that's an excellent idea. Maybe we could even start by a discussion on the sources of information that we have. I just did recently a 2-hour webinar with an Indigenous group on Western, what they might call Western science, and incorporating it with Indigenous ways of knowing or Indigenous science. And this is something that certainly is on the front line in the Arctic, and I'd be curious to find out how much traditional information is used, for example, in European Alpine regions. Maybe I would just start with Derek, if I can. Derek, you've been heavily involved in, because of contaminants, perhaps is more on the front line to some extent in people's minds when it comes to food. You've been heavily involved with Gunter. Maybe we'd go with you first, if you don't mind, Derek. How has that worked? How have you been able to incorporate? I know you work with Indigenous peoples in the Arctic. Do you incorporate that information? And I'm wondering how widespread it is, because I know about the situation in Canada, but I'm not so sure what the situation would be in like Northern Europe or the Austrian Alps. So maybe I'll start with Derek.
Okay, yeah, it's a good point, and one that comes up frequently for scientists in Canada working in the Arctic. And as you said, there's a particular aspect to it in terms of food safety and food security, because so I'll start with that, maybe that side of it. I mean, it's a great concern to people in the Arctic generally, and I can speak for the Arctic Monitoring Assessment Program, which I'm involved in too, that you have a remote area and yet you have food resources which people use traditionally, their traditional foods, which can be contaminated to a point, like for mercury, for example, where the guidelines are not, that not much of it should be eaten, and possibly not at all. And so this whole communication on that side is challenging. But I think that over the years, because this is not new, that this has been known more or less for the last 20 to 30 years, and it's now monitored quite closely. And I think people have, the people that I know and we work with, both Gunter and I work with, have taken this in, but they still feel very strongly to keep to their traditions. And culturally, it's really important in terms of both food and the activity of hunting and fishing. So that's one side of it. I think that it culturally extremely important, and one of the main motivations behind measuring contaminants in the Arctic is to keep track of that, keep warning people if necessary, but also then working at an international level to try to influence the use of and emissions of chemicals globally. And so I'll stop there because that's a whole other topic. But one other thing I wanted just to mention, I think is what John was specifically asking about, is the whole idea of how we work with scientifically with and use local knowledge and traditional knowledge. And what we're finding is that the local knowledge and traditional knowledge is absolutely essential for our actual activity on the ground in the Arctic. And so I guess you could say we can use it. And actually, I think Gunter can probably give some even better examples than me, because I've heard of stories where he was hiring local people to help him go fishing because it was so difficult, at certain times. How do you fish through the ice and that sort of thing? So that local knowledge is really important. And there's another aspect to it, is, well, utilizing it scientifically, it can be challenging, because a lot of it's anecdotal. It's transferred from sort of through hunter to people that they're mentoring and so on, but maybe isn't written down in a way. So this is another aspect of it, that it is difficult to incorporate into a scientific paper. So this is scientists face this challenge, and we do too in our studies on Arctic chars. How do we actually incorporate some of this traditional knowledge? But I think overall, for the projects that I do in the Canadian Arctic, and that includes work on ring seals as well as fish, and on seawater sampling too, we're involving local people, and their knowledge really gets the work done and gives us a perspective on changes that we only see by coming up there in the summertime. They're watching and observing for the whole year. So one final point is that the COVID crisis, which prevented scientists from going to the Canadian Arctic, has actually been a kind of interesting learning experience where our collaborators in Resolute Bay conducted all the work that we previously had done before by themselves. We helped them in terms of sending them equipment, but they did all the work. And it really illustrated that more of that sort of thing could be done if we were organized ourselves a little bit differently, and if there was a bit more encouragement, frankly, from various funding agencies and so on to build that capacity within the communities. I'll stop there.
Yeah, I think at least in Canada, that encouragement is coming more and more, I'm finding, but maybe not far enough. Thank you, Derek. Maybe we'll go first to Gunter, just because that would be a continuation of the contaminant story. And then maybe go to Lindsay and Jakob talking about perhaps more on climate change issues. But Gunter, maybe go you next.
Oh, well, Derek has explained the situation in Canada very well, but the situation over here in, I would say, in Central Europe or all over Europe, except the northern countries where mercury is an issue, is completely different. There is a traditional knowledge, but only with regards to fishing, how to fish, where to fish. But there's no traditional knowledge, of course, on heavy metal contamination of fish populations. But what people are interested in is food safety. So we never, every year we come up with a media release, and when people read in the newspaper about contaminants in fish, they always ask me, they always send email, what about our fish? Are they safe? Can we eat them? And of course you can. So heavy metal contamination and also organotoxicants is in our area no problem at all. The concentrations in mercury and heavy metals are much lower in Austria than they are in the Arctic. And when we talk about high metal concentration in fish, then we always talk about liver, kidney, and not muscle. So nobody would eat muscle and liver except if you make a fish soup, which is, by the way, a tradition in Vienna. But in Austria and most part of Europe, fish eating is safe and it's no problem at all.
No, that's good to know. And yeah, these are issues that are coming up all the time, and food safety is and food security, especially, I would say, especially for Indigenous groups, what we call country foods that are caught, very important for the culture, of course, but are very important for finances. Food in the Arctic, if I every time I go to the few stores that they might have in a hamlet in the Arctic, I take pictures of how much a liter of milk costs. How much, I mean, it's unbelievable what food costs are. So there's also this food security issue that is critical. And again, not able to eat the food they might want for no reason except from what happened farther south, at least in the Arctic situation. Maybe Lindsay could go
related to that. I have a question actually, because when the research is focused on mercury in fish just now, I actually don't know what the primary sources of mercury are in the Arctic, and we just had the mention that it's maybe long range, but could you say something about that, please?
Sure, I'll jump on that one. Yeah, for sure, the major source to freshwater systems particularly is atmospheric transport and deposition. So it's coming in effectively entering in the snow and rain, and plus there's actually a gas component of mercury too. It's a volatile chemical. So that's and we know now that from fact work that John Small has been involved in too, is that when you look at a sediment core or a ice core, that you can see the trends of mercury in that, and increasing over the 20th century. So that's been very much related to emissions of coal burning and other combustion sources. So it's actually linked to climate in another sense of the paralleling CO2 emissions actually. So that's the main way we're looking at it. Of course, there's the geological sources as well. You can pick that up in the same sediment cores and ice cores because of the background in the pre-industrial era. So but it's gone up by about threefold in the Arctic and freshwater systems, and there's evidence to show based on archival samples that in the marine environment, that's like tenfold increase over the centuries.
If I just ask another question while we're on mercury or contaminants, and then we'll move to Jakob and Lindsay. But Derek and Winter, you might be the best to answer this. But as Derek knows painfully well, I'm finishing a book that he's kindly read all the chapters. But I find in the Arctic, there's almost two things. I had one chapter called Sledgehammers, which is like mining where things happen like dramatically. I have another chapter called Under the Radar. And this mercury issue, I think, falls under the radar. You almost need these time series. It's so happening year to year, you wouldn't even notice it. But it's only when sometimes you only need a sediment core like what I do to show over 50, 60 years to actually see something's happening. And where there's probably a whole lot of sources and sinks that we don't fully understand yet. And Derek, I'm just putting out two right off the top of my head. And it could be complicated. We have glaciers melting into lakes. One could argue that the glaciers have been this ice box of contaminants, not just water, and now they might be being released very quickly. They might also be a dilution effect of the water, so it's probably not straightforward. And just another issue that happening under the radar is permafrost thaw. What is, that can be changing all sorts of things. So I'm just wondering, do we have some understanding of those two, what I call under the radar factors that we often link with climate warming?
Well, yes, in fact, it's a good opening to bring in the glaciologists and the environmental chemists, because in one study that we're involved in, a series of studies at Lake Hazen, which is the picture behind me, the glaciers have increased in their flow and brought in much higher sedimentation rates to the lake. But an interesting thing, when we follow the char in the same lake, we haven't seen the mercury in the char, jumping up because of increased mercury deposition. Yet the lake is the glaciers are definitely delivering their historical component of deposition of mercury and other pollutants as well. And in the case of permafrost, there isn't as much work. I have to say this is an area that really needs more study, because it definitely has a reservoir of mercury and other pollutants. We have a study site on Melville Island where we're looking at this, and we are seeing increasing mercury in fish, but we can't say for sure that it's just the permafrost, because the other effects like turbidity are affecting things like the condition of the fish, their weight, their food supply, so that it gets complicated in that regard. But I think this is, these historical perspectives from archival material are really important to get a handle on this.
No, we're definitely in a multiple stressor world. Maybe we'll move on to Lindsay, and then after Jakob, maybe do you have comments? I was just curious if, especially from the glaciological perspective, some of the issues we've talked on, but also maybe not indigenous knowledge, but traditional knowledge that you might be using in, say, Austria or other Alpine regions. I think of paintings and old photographs, perhaps, but there's probably a lot more.
Actually, yeah, thanks for the question. I'm not a heavy user of historical documents at the moment, actually, in my field research. But of course, there's a tremendous archive of information stored here in the Austrian Alps, stored by the Austrian Alpine Club, and these historical documents can certainly be of great use to look at comparative change, and that is also I think the Austrian Alpine Club leads the kind of community science effort to measure length changes across as many glaciers in the Alps as we can. But I do have something to say about the release of legacy pollutants from glaciers, because I think it's quite an interesting issue, particularly like in the case of these pollutants which were outlawed by the Stockholm Convention, because these are, I believe, the so-called like legacy pollutants. And in this case, then we need to understand when the melting glacier surface is exposing ice, or the most ice, from the 60s, 70s time period where there was like maximum use and deposition of these contaminants in the snow and therefore in the ice. And it seems that most of, in the case of the European Alps here, it's most likely that legacy pollutants have been largely released already. And that, I was curious when, Gunther, when you mentioned that the 80s was maybe like the heyday of contamination in water, you're not really referring to the melt out from glaciers, how you're talking about more downstream effects.
It's more downstream. So I was talking about industrial effluents.
Yeah.
And all the major rivers in Austria were I would say, heavily contaminated by lead, by zinc and so on. So
Yeah.
I was
Okay.
this was not really true for the high mountain lakes, but
Yeah.
there's also one interesting thing which is maybe under the radar. It's the nickel thing. So it was not me; it was colleagues from us from the University of Innsbruck, and they have found increasing concentrations of nickel in high mountain lakes and in the creeks up there. But the funny thing is, it's not coming from the bedrock, so the concentrations in the bedrock is low. So nickel is coming from the permafrost, but we don't know why it's there. So there are many things to do in the future.
Yeah, this is a fascinating topic, and recently, in fact, earlier today, I was working with one of the collaborators on that work to try and give a report of nickel concentrations in some of the water supplies for some alpine huts. Mm-hmm. Because again, these levels are not high enough to be dangerous for visitors, but they're a little bit elevated. And if you were spending your whole summer with your family over successive summers living there, some of the people operating these huts are interested in having more knowledge about if there are heavy metals melting out of the permafrost. But you're right, this is still a very, very much an open question. It's a mystery, actually, still. Mystery. That we have the observations of the rising levels, but we don't have the mystery is not solved yet, so it's open.
Thank you.
Maybe Jakob has something more to say about the changing glaciers around our region.
And possibly even from Greenland, for what you mentioned. I was very interested what you said earlier about your 5 years in Greenland, but please go ahead.
Yeah, I can add a bit on that, I guess, on several levels. I mean, if I pick up the pollution thing, in Greenland, that is, of course, very relevant, and I can just add a very exotic spice to this by telling the stories of the Cold War remains that are buried in the Greenland ice sheet, and they are actually a symbolic manifestation of current climate change, because they were built onto something nobody ever thought that will really change very much in future, at least not in the perceivable future. And then a few decades later, people started becoming excited and said, well, actually, there was a lot of activities on this ice sheet. It was snowed in now, but now the ice sheet is melting. When is it coming out? And quite a lot of research has actually evolved around these issues now. And a rising equilibrium line altitude in Greenland makes this also a very interesting point. To some extent, you don't even need climate change to make this at some point in the future a problem, because the ice is moving, and at some point this will be exposed. It can be in hundreds of years, can maybe even take millennia, depending on where it is stored. But understanding, having a kind of a knowledge on what actually is within human-made contaminants in the ice sheet is something very relevant and extremely exciting and important at the end. I would like to make a small point also to the use of traditional knowledge. I have little experience with using really traditional knowledge, because I think, as I think Derek pointed it out, it is very complicated to make use of it, because it is so connected to perception, and we all know that just tales of snow heights can be very misleading. But what we can use traditional know-how, at least for, is definitely all the logistical support. I totally agree, but I would even say this is too little. We can also use it for getting an idea about variability, because local hunters, for instance, they know exactly where their ideal routes to the spots are where there is usually reliable fishing grounds, just to say something. and they wouldn't choose a route that is not a route that works out every year, and they know why that works out. So we can use it from a food perspective, definitely, but we can also use it from a transportation perspective, and that's also what we try to implement. And finally, I stopped with a comment on not traditional knowledge, but community involvement. And there we had some very good success stories from Greenland, I would say, where we, for instance, in a very nice project, implemented a moving weather station on a vessel that goes in and out into a fjord at a certain day every week. So we got actually a very good new understanding of the climate gradients on a very small scale. And at the same time, people were interested in it because they were monitoring, they were using this vessel for normal transportation, and they were excited that they now have a nice visualization of the weather and commenting on it. And I think that was a good way to also include it in this discussion, to think of not only traditional knowledge but also community involvement.
Definitely, and I think, as Derek pointed out, like very often the residents of a region are really the best placed to do the measurements. With a small amount of training, there's enthusiasm and definitely adequate skill to do so. And I really hope that our community keeps moving in that direction.
Yeah, I think I think in Canada, it's I'm sure if you're Indigenous or in these communities, it's going too slowly. But I'm quite surprised how fast the mindset has changed, if I cannot use another word. And people are now scientists are very sensitive to these issues and are very, I think, very positive in trying to make this work, and realizing that, when, it wasn't that long ago that the way you did science in the Arctic was you had some small university group or government group would fly up for 3 weeks in the summer, do their analyses, fly back, do the analysis in their lab, publish it in a journal, which had absolutely no relevance to people living in these communities. And it really was, what it's referred to as colonial science. And I think that's changing very quickly, at least in Canada. And I think it's definitely changing in other parts of the world as well. And I think that's very important. And there's no reason that the people living there shouldn't be able to do the monitoring themselves. And I think we're slowly moving in that direction, and it's something we have to do. And I think COVID in some ways forced that hand that, what are we going to do? We have no data. Well, maybe they could do it. They do a pretty good job at it. It wasn't a problem. So, no, that's very interesting. It's something that I am, if it's in environmental sciences, we do not have the luxury of excluding any solid information. And there is a lot of solid information out there that we have been excluding for decades. And I think that is changing. We're talking a lot of bad news here, and maybe that's the whole session's going to be bad news. But I just wondering, are there any good news stories here? And there are some potentially in the biological sphere, but even those are probably not good news stories. But there are always winners and losers with, let's say, climate change, or if your competitor is downtrodden, you might have a better shot. I'll just show one example. I mean, we saw we're seeing the greening of Alpine regions, the greening of, we call it shrubification of the Arctic. The plants are moving farther north as one example. Species are moving farther north. We were just talking about Arctic char not too long ago in some of the Arctic islands, and I think also in Alpine regions. Arctic char was the only fish pretty well in some of these aquatic systems. Now, I'll give one example. In the Western Canadian Arctic islands, salmon, Pacific salmon, are now entering the islands. And so is this good or bad? On the positive side, it's another nutritious food source, salmon, high in omegas and all these things. In fact, our Canadian federal government, Department of Fisheries and Oceans, have developed a cookbook for salmon in Inuktitut in the local languages. But also, this is probably displacing the char in this case. And I'm just wondering, are these good news stories? Are they really, just because species are on the move? Let's just use one example. I think in general, they're just, they're probably still bad news stories, but you can put a spin on it. I don't know, maybe we'll go back in the same order, if, especially since I started with, it doesn't have to deal with fish, but are any of our stories good news stories? Maybe I'll start with you, Derek. Do you have any comment on that?
Yeah, well, it's interesting because there's a bit of traditional observation as well in Resolute Bay, which is much further east from these sites that John mentioned. They're also seeing salmon, and so we get these reports. So, you know, and it would be interesting if we, I think the local people do interact with the fisheries scientists to some extent, but it you know, documenting that better would be very valuable. And it's a case where everyone kind of locally knows it, but it's not being documented as well as it could be, I think. But I'll give you one example that we do have, is that we've been looking at the growth of char because we can measure their weight and their age. And in one lake in particular, where on Melville Island, we're seeing mercury is declining in the char, but it's not necessarily because the supply in the local watershed or coming in from the atmosphere is declining so much. We think it's the growth rate. They're growing faster. So the warming is increasing productivity in the lake somewhat. It's still very clear. It doesn't look green or anything. But we've concluded that there's a faster growth rate. We're also looking for this in the other lakes that Gunther is studying. We're not quite seeing it so much in lakes further east where we have the same sort of data. And so maybe it's a one-off, but you can sort of see the hypothesis there, that as the lakes warm up, the waters are getting warmer, there's more ice-free time, and there's a bit more productivity, and the fish have more to eat. So in a short run, until the lakes get turbid, you know, there seems to be a bit of a gain for these landlocked char.
Yeah, that's just one example. Of course, there's birds and other things coming in as well, and it's a moving target, I suppose. Maybe we'll go in the same sequence. Gunther, do you see good news anywhere, or is it all really?
Well, Derek mentioned one lake, and it's definitely true. It's not published yet, but there is one lake, you know, in John. It's Resolute Lake, and it's very clear that that fish are growing faster to a bigger size within the past 20 years. We are taking samples of that lake, so this is really clear, and it's of course climate change. It's maybe not the temperature alone, but and the effects on metabolism, but it's a change in food availability and in the food chain. But there's also a good example from Austria. By the way, Arctic char in Austrian high mountain lakes is not a native species. Arctic char in Europe and in Austria is a relic from the last ice age. And when the ice retracted, Arctic char survived in the deep, large lowland lakes. The reason why Arctic char is occurring in high mountain lakes is people have stocked them in the times of Emperor Maximilian in the 13th, 14th century. So since that time they are there, but they are not native in those lakes. But when we studied Arctic char from a high mountain lake 20 years ago, we found, as I explained, very high heavy metal concentration in fish. When we resampled the lake a couple of years ago, we were completely surprised because we didn't see an increase in cadmium and lead, but a steep decrease of heavy metal concentration in fish. And the reason for that is climate change. Due to the melting permafrost and other weathering processes, the alkalinity, calcium concentrations, cation concentrations, and the pH increased significantly in the water column. pH increased by almost 1 unit, and that's the reason why the bioavailability of cadmium to fish decreased. So that's the reason. So climate in this lake, climate change had a positive effect. Heavy metals in the fish population went down, but all those changes are usually a matter of the viewpoint of the observer. So is it good when salmon is entering Arctic waters? Of course, there is a species to eat, and to fish, but on the other hand, it will change the entire ecosystem completely.
Yeah.
So it's difficult to assess, is it good or bad?
So we're in complicated times for sure. Just remind the audience, if they have questions, please put it into the question and answer period, because we're going to move to that soon. But I'd like to continue on with Lindsay first, maybe, if we'd like to add anything on winners and losers or anything on this topic, and then we'll go to Jakob.
Yeah, I think I find this good bad question quite challenging, and I think in terms of like changing the ice and changes in particularly the glaciers and land ice, that really is a question of vulnerabilities. There are certainly some mountain regions where the loss of ice isn't expected to have a profound impact on the local communities, even if there are shifts in water supply and ecosystems, that there's sufficient precipitation that these basins perhaps are not critically dependent upon the glacier meltwater, or it's a small component of the total. And of course, there are other regions where, particularly if there are very dry seasons and there's a heavy dependence on irrigated agriculture, and then the glacier meltwater has become, at least in recent decades, a very large component of the base flow, and that provides this irrigated agriculture, the water that it needs to feed the local communities, and also like raise capital from cash crops. So I think vulnerabilities to those changes are really important, and we need to understand them. And likewise with the melting of Arctic ice and its impacts on the ocean. Those impacts are not, as I mentioned, like fairly distributed. But maybe Jakob wants to jump in on that, or the comment on the mountain glaciers.
Yeah, I mean, I agree with what has been said before, and I find it also, in an interconnected world as we are living in, it's probably impossible to talk about isolated winners and losers, because eventually people in the Arctic may have events for some time, may experience some positive development, but they will also suffer from larger scale problems, of course, at the end. And I see this very much. I mean, there's a massive potential in Greenland, if you think of climate change, there's so much water resources that can be released, and all the transportation gets easier if there is less sea ice. So there's many things, if you have the right brain or the right head on your head, that you can see very positively. But on the other hand, that of course creates an increased dependence of these conditions, and we still struggle with areas where variability is enormously high. And even if some mining exploration happens in a year where actually a fjord is very easily accessible, that doesn't mean that this fjord is easily accessible throughout the entire exploration period, or even the time when they want to extract the minerals. So I think it is very difficult to attribute these the current changes to a sign of positive or negative. And especially if you think of Arctic infrastructure that is in place, of course we all probably agree that we are currently observing very difficult times, and the investments they are currently doing, they last very longer. And I think the point Lindsay made on availability of water and the impact on people is something we should not forget, that this is so dependent on the seasonal cycle, and this is of course also true for the Arctic, and we should consider this in future decision making.
And I would add as well, like while we're talking about sort of just Arctic and Alpine environmental change in general, that at a planetary scale, we're really seeing like strong degradation of the biodiversity. And I think I'm not an ecological expert, but my understanding is that as long as the maintenance of biodiversity is important in ecosystem resilience. And one of the things that happens with change in the colder parts of our planet is that some species get squished out. There's no real niche for them anymore. And so this is a particular way that we're kind of eliminating some biodiversity from these particular regions. And I suspect, although there'll be some differences in the ways that things play out, that overall we expect to have more, more vulnerable ecosystems and more people reliant upon them. And this isn't going to be a win overall,
No.
as I see it. Sorry to be negative.
Yeah, it's going to be a very different ecosystem. You know, even some of the work I do, it shows that diversity of organisms is increasing, niches increases, but that's not natural either. You know, like, I mean, to make a simple example, the polar bear is there. Now we have polar bears and grizzly bears. Is that on one level that increased biodiversity, but is that really a positive? You know, it's sometimes very hard to use some of these measures the way we might use them farther south. I think we are dealing with a different type of bank account almost, what's good and bad. As a paleoecologist, I tend to think what's natural is good. That's just sort of the way, you know, we call it reference conditions. But it's definitely changing very quickly in so many different ways, you know, and with these new species arriving, it's really in many ways, a very different ecosystem. Different birds have arrived, certainly different insects. We know that when we're on the front line. It's a complicated world, and we're not really sure how this is changing food webs and everything. It's really.
Does anybody in the room know if Arctic and Alpine insect life is actually diversifying and increasing? Because it's one of the, it's one of the kingdoms that is under threat at a global scale and a very important foundation for ecosystems, but I'm not aware.
Yeah, I know this. I know, for example, in Inuktitut, the language of the Arctic, they're making up new words for new species arriving. So it's really changing quite rapidly. And we're living in a complicated world for sure.
Winners nobody knows about the resilience of this new ecosystem.
Yeah, and also,
are they resilient? Are they more stable? Is the stability decreasing? So
it's not simple. I use the word winners and losers, but it really is the perspective who's asking the question to some extent. So it's complicated. We have a few questions. I would just want to get to the audience that we have. One of them is that one of the items that may not be factored into Arctic considerations is the cost of living in remote communities. And I think we touched on a little bit on that. It's a very significant factor in food security, if nothing else. You need a pretty good salary to go to the store and buy all your food if you're living in some of these small hamlets. I don't know if anyone else, but anyone else wants to comment on that question. But I think that George asks a question. He asks it for Derek, but I think we can all comment on it. But not only, he says at Derek, but not only, he says, is local traditional knowledge, particularly in the Arctic, still useful for adaptation, as most of the environment has changed beyond the space of traditional experience?
An interesting way of looking at it, but I would say the people I've met are very adaptable. I think the Inuit people generally in Canada are remarkably adaptable, because you think of the conditions they're living in. I'm talking about living in hamlets, which everyone's living in housing and so on. I'm not talking, I'm implying something else, but I'm just saying that in terms of just hunting and fishing and how you do that when it's -20 to -40, or how you travel across the land and everything. I'm always just admire their capability. And so I'm not too looking at that question again, but I think, of course, things are changing rapidly, but I think in that regard, the cultural experience that the people, at least that I'm not a sociologist, but I think they're keeping up with that sort of thing, a bit like John said about coming up with new names for species that are or insects that are arriving in the north, and that wouldn't be a particular issue. I think where the issue of traditional knowledge and science kind of has difficulty interacting is simply how we put it in, really include it in our interpretation of results and so on. It's a bit challenging for everyone. It's a bit challenging on the one hand for people to explain to us, the information they have in their heads, and for us to kind of put it into our science conclusions. So that's, but that information keeps coming when you talk to people. I don't see them having trouble on the adaptation side.
Oh, excellent.
Well, I would support what has been said by Derek. I think to ask for and to include, if possible, traditional knowledge shows that we as scientists respect the people who are living there since centuries. And also in the European Alps, the changes are very fast, and we also need traditional knowledge there. Just think about industrial agriculture. If you want to get rid of industrial agriculture, if they want to come back to more traditional methods in agriculture, you have to use traditional knowledge, because people know, the old people know how to use them. So I think it's extremely important to include it in both regions, Arctic and Alpine landscapes.
Lindsay?
I have a small comment on that, because I also think that traditional knowledge can be very useful for setting baselines and shift points. We used to be able to do this until, and now we can't. But it's really a cool example, Gunther, that you bring up the agricultural example, because actually I know that Georg was involved in a project in the Peruvian mountains where local traditional farmers were reporting a decrease in precipitation, which wasn't reported by the scientific instrumentation, because what's actually missing for their style of agriculture was a particular kind of very early season, planting season, light, gentle rain, doesn't wash the soils away, like seeps in, and this is when seeds are planted. And so there can be extremely subtle changes recorded in traditional knowledge that are actually very difficult to record. And I think sometimes the answer lies in exploring the confusion, like when the two types of information don't match, there can be a story in that mismatch. But it does take a new approach and a bit of innovative thinking and communication to draw it out. So it's really some exciting possibilities. And of course, with that, presumably some dead ends, but it's certainly worth exploring. Thanks.
No, excellent. Jakob, do you have something to add?
No, I mean, I think it's also, it can guide our research paths also if we follow and try to follow understanding of this traditional knowledge, because then at least we do the research that is relevant for the people. And I think this is what we all should have at least as one aim. So I know this in Greenland, we have this condition that again the routes people use in order to get from one village to the other village can be an example. But just by getting quantitative information from traditional knowledge will be difficult, but getting access to these tipping points or these vulnerability issues again can be a relevant one. So I think it bears some potential, but it also has to be taken really with care, especially given the large variability and the subtle trends we are observing compared to the large variability.
Yes, I was talking with a colleague of mine who's been very closely involved in some of these issues, and his advice was quite clear. He says you not just get the answers, but you have to talk to whether it's the Indigenous people or the people you're dealing with, the local stakeholders, whatever words you want to use. The key is to get there early and find out what questions they need answering. And once you start answering the questions that are of grave concern to them, already a bond is made, and the results are, they not only is there help in getting the research done, but you get information that you wouldn't have otherwise. So it's not so much coming in the Arctic, coming from the south and just coming with your questions. Be ready to spend some time to find out what are the questions that they feel need answering. And that comes to a much more socially justice, if you like, conclusions, for lack of a better word. Does anyone have any final comments? I've been told I have to stop certainly before 5 minutes from now. So we're at the very, very near the end. I don't see any more questions. One question is this being recorded? And I see it is being recorded, so I assume this will be available afterwards. I just see the recording symbol there. Does anyone have any final comments in the last few minutes before maybe we call this session to a close? I don't see any hand going up. All I would do now is I just like to thank the organizers, thank both the Austrian and the Canadian academies, and I especially like to thank the staff behind the scenes here and the panelists. I thought this was an absolutely fascinating session, and I wish we just had more time, and perhaps at some stage we could actually meet in person, which is what we plan to do. But if not, I'd just like to thank everyone, and please stay tuned. There's other panels ongoing, and all of them look pretty interesting to me. So thank you very much. Take care.
Thank you very
Thanks
much.
for guiding us, John. Bye-bye.
Take care.
Yeah,
Thank
thanks,
you.
John. Thanks a lot.
Bye-bye. See you, Derek. Bye.
Bye.